Well, I'd like to again thank the speakers of this morning and the audience for great participation, and those of you online listening to our discussion. And most of the panelists have been introduced yesterday, except for Rick Woychik. So let me just take this moment and introduce the Deputy Director of National Institute for Environmental Health Sciences. We're very pleased not only in great participation that NIEHS usually extends to these workshops, but also for providing funding for this activity. So Rick represents big government and this big data workshop as well. And if you look at the description or one paragraph that we have for this session 4, I'd like to just kick off a discussion maybe with a couple of questions, and then we'll go to the microphones and to the online questions. But let me just begin and maybe ask first our speakers, and maybe Rick, you can ask as a representative of the government organization on addressing this dichotomy or two different approaches, as Steve put it yesterday, you know, the top-down versus bottom-up. Who should direct big science and big data? Is it the government should decide what the challenges are and provide support for it, or should the government agencies listen to where the chatter is and where the beer and diapers you know, connections are made, and then try to invest there? So, you know, maybe briefly if you can share your comments on that. So.
Yeah, so part of the reason why I asked my question yesterday around ENCODE is, you know, what was the governance structure and how did they organize that? And part of the response back was, I think that was very much a top-down approach where NHGRI was very much involved in conceptualizing the project and then putting out, you know, RFAs and granting mechanisms for people to self-assemble and generate the data. Although in discussions with Stephen this morning, and unfortunately I missed your talk yesterday, I was talking about budgets and other things in Bethesda. And in hearing Kevin's talk this morning and actually hearing Suzanne, I think there's a different model where it doesn't necessarily have to be the top-down approach. But I like this concept of, you know, getting, say, leaders within the scientific community. Now, the extent to which government and NIEHS can help to bring those people together, identify those individuals, bring them together, but let the ideas come from them, and then have these ideas then percolate up in such a way that we can develop. I think the key thing is developing that grand vision around a given project. And that vision then becomes the glue that keeps different individuals interested in the project and also gives them a sense of, well, I understand how this is working. And then part of that vision is around the vision is developing that scientific plan, which you very nicely illustrated in these, you know, having all those individual pockets kind of at the nucleus within this larger circle which you define the project. I actually asked you for your slides. I hope you'll send them to me. But I think that would be a very interesting model to think about. In fact, if there's one thing I'll take away from this workshop, it's this awareness of the possibility that there may be a paradigm shift. Actually, Stephen was commenting also about, I guess it was the astronomy community. It was astronomy or astrophysics?
Really astrophysics, but just a quick point on this, which is it's helpful the same way you talked about NASA and what NASA has done. The best thing is to find adjacent areas that have solved things in lateral and leverage. And I think the software industry and what they did with GitHub and others is a good example. But I think the examples of data integration and making it so that actually citizens could report their information all the way up to the Hubble telescope, and how you integrate that, I think, is similar to what, Kevin, you were talking about.
Kevin and Susie, would you like to maybe comment on this as well?
Sure, definitely. You talked about the role of government, and it's at USGS, that's a really, really interesting question. Once upon a time, we were all over the landscape mapping the West, you know, or actually it took us about 55 years to cover the nation one time with topographic maps. And it was only about 30 years ago that we completed that once over. We spent a long time with people out there surveying the nation. And the last 20 years has been, we've seen this absolute explosion of geospatial data becoming corporately sold, becoming a commodity, basically, to the point where organizations are driving around with their trucks with the cameras on them, And we're out of the business of collecting road network information. We're still hanging on to elevation and hydrography and important issues about science and the environment. But that wave that really changed the role of government, right? And so we've been really kind of trying to focus on what is our core competency, and there's definitely a very important aspect of collecting data and putting it into the public domain. I'm not so sure that it's really the role of government to enhance that data in ways that are usable. I think that is up to the imagination of the universities, of nonprofits, of the whole world of people that are consumers of that information. I think we've seen that really clear in the satellite community for years. Not many of us can launch our own satellite with sensors on it that can circle the globe and collect data, but all of us find that data is really valuable and useful. In the late 90s, there was a lot of pressure on the USGS to try to make the Landsat series of satellites commercially based. It didn't work. It was spun off to a corporate kind of entity. The price that had to be put on each satellite seen was such that only the most wealthiest organizations with really a profit-driven analysis requirement were able to capture the scenes, and it went back to being run and data delivered by the government. And in fact, we made a big decision about 3 years ago to just make all that data completely freely accessible. And we've just passed something like 6 million downloads of scenes in the past year. And so I think there's a big important issue of collecting data, putting it into the public domain, and I think that's a real clear role for government.
And Susan, do you, what can you also cover, maybe touch on the feedback that you've gotten from your big data challenges, and what do you hear from the community that you fund, and do they think that this mechanism is working for them, or your, challenge idea actually comes from the fact that you cannot necessarily control after you give the funds, what the product is being delivered?
Okay, so before I get to the challenges, I'd like to answer the first question, and that is that I think that we have to figure out how to integrate bottom-up with top-down approaches, and I think that I'm agreeing with everything that's been said. So we have to let communities kind of figure out for themselves, what it is that they need to do, because they're the ones that have to do the science. They can't be told, you've got to use this standardized approach over here, because it may not work for them. Having said that, it is really good if there is leadership, if there's vision, if there's a plan, if there's resources, right, that people can see are out there, right, so that they can see something bigger than just their small archive, their small community of science, right? So how do you do that? Well, you can, at NSF, we have several methods. One is this EarthCube method. We also have a data infrastructure building blocks program where communities kind of self-organize with their nearest neighbors, right? Okay, who would benefit if you shared the data? Tell us what you will do to federate, to integrate, whatever it is that you need to do, and tell us what those big new science questions are that you could answer. And so I think that we have to do that. Having said that, they have to plug into something, right? Something bigger, right? So having this something in the sky that I'm pointing to that you could plug into really gets to something that's kind of national, bigger, and so that requires standards, it requires good metadata. But the government can provide the leadership and provide the resources, for folks to do that. So back to the competitions and prizes. So the response is great. We have not announced the first set in terms of the big data competition, but it enables us to reach out to people that normally would not submit grants to NSF, right? So the retired NASA scientist in Vermont, right, isn't going to submit a grant to NSF. the college student who's not yet a faculty member. So we're reaching out to people that have great ideas, and so that is valuable to us, I believe, as a country. We also have not limited it to the United States necessarily, at least at this point for ideas. We're happy to take good ideas from wherever they might come, because then we kind of own them. They're our ideas.
I want to follow up on this important concept of the role of leadership. I think that we have seen a progression from people waking up to the importance of collecting data to, I think most people are aware of the complexity of integrating the data. I'm not saying it's going well, but I think the one that we're just beginning to touch on that I think leadership is really needed in has to do with the enabling recognition that allows ideas to be evolved pre-publication. So the data that is being worked on, and this is where I think the physicists and others can help, where the author list, remember, is alphabetical. Okay, the recognition is coming long before publication. You can speak to among peers. If we're going to make sense out of this data, I think the siloed approaches are ones that are going to slow us down. And so where there are opportunities to run challenges, I think we have to look at how we incent people to share their models, not just their data, and that those challenges are ones that are open enough that actually they're sharing their models, not their data. And I don't think we have, and this is about government, it's about leadership, I don't think we have the incentive structures that have people going, I would be glad to share my models. I'd be glad to share my ideas. Why? Because they don't have the recognition. And until we set, they want to. If you talk to Titus, you talk to other people, there is a whole generation that are ready to blow through our problems with amazing passion, okay? But they're sitting there going, will that allow me to get to in my department? And that's what's slowing it. So I'm sorry to go on, but I do think that I'm going to put a challenge to the NSF, to all of those in government. You have a great opportunity for leadership when it comes to not just running challenges, but ensuring that the way that we run them has people incented and rewarded in ways that actually allows them to do what's natural for them to do.
Can I tag on to that? I love those comments. And if you look at the scientific community today and incentives, the real value in publishing ultimately is citation, right? Is that your work is cited, that you've contributed to new knowledge. And we need the same kind of citation orientation around data, that to get to that other eye vision that I had in my slide of, I get credit for contributing data to the community. If we could create that incentive, no question. And then to your comment about generation, and just I can say this, I think, because I'm part of this problem. But when I look around the room, I don't know how many of us could raise our hand if I said how many of you are under the age of 35, and that group that's coming up behind us. I refer to them as digital natives, and we're digital immigrants. It's just instinctive for them to share and to consume data from all kinds of places. And you're right; they're coming up ready to push through all this. So I guess I'm just confirming what you said. But I think if we could somehow set up a system of recognition, citation around data contributions, that would take off in the new world that's coming.
So I totally agree with this idea of creating the incentives, and I think that is the responsibility of federal agencies to push these themes and then integrate them into the universities and other places that can actually reward people. There's another component, though, of data submission that I'm hoping that many of these databases can be designed in such a way that if individual investigators share their data, there's value added for them. And I think that's a really key point here. I mean, an example would be, say, a genome sequence. You know, a single genome sequence is fine, but it's almost useless just by itself. It's only when you share it with other genome sequences that you can begin to realize where the sequence variations are. And if you couple those then to clinical outcomes, your sharing your data becomes meaningful for you. And so the extent to which we can design you know, the electronic submission and seamless integration of data into databases, and then there's some incentive for the investigator to do it because they can enrich the quality of their own data. I think that would be something that we really need to keep in mind.
Can I just jump in here for a second? That I think that we need a change in our culture. And so when we talk about data sharing or we talk about growing a national data infrastructure, what we're talking about is cooperation. And what we're used to as scientists and engineers is competing with each other, right? So you submit your proposal to NSF and you're competing against all the other people who submitted proposals to NSF. And it's the same thing at NIH, the same thing any of these funding agencies, right? So we're so used to this competitive nature, and that's what makes us hoard, right? Because we want to be the first one out there with the discovery. And so changing that culture, I think, is starting to happen in the universities, but it's really, that's where it has to happen with the young people working more on teams, understanding that there are benefits to you when you actually share, when you work together, and that hoarding may not be the best thing that for your own benefit, right? But how we actually make this big, huge culture change, I'm not sure. We still have this problem at NSF of people wanting to compete, even in the kind of cyber infrastructure programs, right, rather than figuring out how to cooperate. And so it's a big challenge.
So I think I'm going to preempt what I expect Lou's comment to be. So on the training front, we have a real, we have a very clear workforce gap, certainly in biology, which is where I'm mostly engaging with these issues. And I think that Suzanne alluded to this with respect to industry. There's going to be a big gap in the number of people that are capable of working with big data in the upcoming years. And so figuring out how to bootstrap this culture of big data in fields where it traditionally isn't present, like biology, and also just the general training seem to be things that could go together very well. And so we've applied for one of these IGERT CIF 21s and at Michigan State, just so you know, okay. And yeah, and what I like in terms of an idea I'd like to suggest is, right now there's only going to be 2 of these CIF 21s funded, and we all know there's probably going to be 10 or 20 of the 50 that were submitted that are quite good. And it seems like a really good way to bootstrap the culture and get the graduate students that do all the work trained in these methods is to fund more training grants and less, frankly, of the research. The research is going to be dependent, doing good research is going to be dependent on being able to make use of the data. So you can almost just let that happen if you can figure out how to train the graduate students and develop the training programs. And there's nothing that gets university education initiatives moving faster than NSF IGERT proposals. So that's just define the priorities, the societal challenges at a high level, and then train the people that are capable of addressing them well, and let the middle sort of sort itself out.
So Carolyn, I'd like you to comment on this, and we'll go to the microphones just to open this up to the audience.
So I just wanted to get back to this cultural change and I'm curious on all of your thoughts about how to re-educate the educational institutions in terms of their evaluation. So I'm not under 35, but I enjoy my job. What's that? Yeah, I was going to say I'm over 35, but frankly, I get a lot more enjoyment out of my work when I'm collaborating and working with others. And at my old institution, I had a comment during a review that this is really great that you're working with other people, but you have to make sure that you have a couple papers or grants that are your own project. And I thought these are my own projects. I'm just working on them with other people. It's not any less mine or yours, and in fact, by working together, I think we end up with a better outcome. And so, we can all move along that way, but getting back to this incentivization, I think the academic, at least institutions, I think, need to be helped along in that process, and I'm not really sure what needs to happen to make that happen, but...
Eleanor Ostrom studied how you shift institutions. She won the Nobel Prize. And the trick is in identifying where the pivot point is. And I'm going to argue that actually funders may be the pivot point. So you can say it's the publisher, you can say it's that. But I actually have found that the communities where there's leadership and the funders are doing it, it sort of moves everyone else. And I'm sorry but I do think that since every piece is dependent upon the other, it's hard to identify what will tip it. But I do think that situations which I think are now occurring, and I'm terribly encouraged, where people are saying, we're going to reward you for doing this, or here is where the funding is, whether it's in training or others. Don't forget that that can, in a complex system, still shift it by being, I think, the most critical point. So I think, again, government has a powerful role.
Well, thank you for a very stimulating discussion, and we would like to welcome comments. So we'll go to the microphone.
Kate Guyton from the USCPA. Thank you for that really excellent discussion and also the presentations. And there was a concept that Kevin had on one of his slides about the sustainability of your investment. I wanted to hear maybe a little bit more from Kevin about what are the attributes that really would mean that to you. And I think some of that perhaps you've already kind of highlighted in terms of the community engagement in creating the incentives so that people can continue to develop it. But I think being in the government and thinking of, for example, the air toxics example of where we put out those data and didn't really anticipate all of the great research that's come out as a result of providing access to it, allowing for the innovation that's going to come from the academic community. So kind of where you see the government and perhaps specifically the attributes that you may have had in mind when you put that point on your slide.
So that question or two, I could take that question at a very high level or answer the direct question about the community for data integration at USGS. The reason it was on my slide was that very technical folks know that how you go about solving an individual challenge of a scientist can or cannot lend itself towards scalability, toward something that could be then picked up and used over here by another scientist or plugged in a similar situation, yet different discipline. And so what we're looking for specifically within USGS and that community is for things that are replicable, that are scalable, or that would make a contribution toward, like in a good example would be this tool that we developed that helps scientists curate, upload, and properly register their data into a corporate repository, is an institutional-oriented thing within the USGS that guarantees, it doesn't guarantee, but it enhances the sustainability of that data set. And so those are the kind of very specific technical requirements we're looking at within the community with competing proposals that get put in to do work on behalf of this data integration goal that we have. Your question of sustainability and the government's role in it is a much larger question. One of the great benefits of NSF is the funding that goes out to universities that creates all this innovation, the competition that exists there that keeps us pushing the edge of the envelope and creating all these breakthroughs. Someday, though, that grant money runs out, and the question then is, what happens to that project? What happens to that data? I mentioned that the USGS has this long history of long-term monitoring data sets. And that's incredibly valuable because over time, that data becomes more valuable, actually, to be able to look back at the hydrologic record from 150 years ago continuously to today allows us to do certain inferences about how the climate's changed and so forth. On the other hand, it makes it really difficult for us to be hugely innovative and changing. Some of the methodologies are intentionally made static, so we do have that comparability over time. So your question of sustainability at the higher level and the role of government, I think, is a really much bigger one that's a tougher nut to crack. I think programmatically there are certain, we might be able to say there are certain data sets or certain programs that have such ubiquitous implications that they deserve to be long-term funded in a federal program. I don't really know the answer. I don't know the complete answer to that question, and I think it's a good one. Maybe some of the other panelists want to weigh in.
I just want to weigh in on an issue of funding. So there are limited dollars in the federal budget. But in the interest of collaboration and cooperation, I'm wondering in the future whether there may be also the opportunities for there to be greater cooperation between academic and industrial divisions. So, currently you have many industries, chemical companies and pharmaceutical companies developing their own databases. Some of them are made public, but there's not a lot of cooperation. So could it be that there's just a greater awareness that there is kind of pre-competitive information that can benefit both the chemical industry, the pharmaceutical industry, as well as academics, and developing a more robust discussion about how how can industry co-fund some of these fundamental databases and data sets that can contribute to productivity in both sectors. So an example that goes way back would be the SNP consortium. And that was a very productive interaction. Many pharmaceutical companies and the Wellcome Trust, the NIH, all contributed to create this data repository. That was a limited scope, and I'm just wondering if we can learn from that and be thinking as we move ahead to innovative ways of getting more money into support resources that will benefit broad sectors.
I think, Rick, you're bringing a really good point, and George pointed out that one example of that for the toxicology or environmental health community was the REACH data sets that ultimately have transformed into a fee-for-service database rather than being a resource submitted to a regulator that then can be opened up. So I think this is where the role of government extends not only to the funding agencies but to regulatory agencies and them pushing the envelope on the CBI and other issues that they have to deal with. But you bring up an excellent point. So Suzanne.
I just want to introduce another way of thinking about sustainability that I think is really important. So at NSF, we have some programs that are focused on low energy, no energy computing, right? And so our big, huge data clusters, use some large, significant amount of electricity that's used in the United States. And so when we're talking about data and what data to preserve and which do I throw out and, it may be important tomorrow, we are getting to some technological solutions where you can have no watt storage, for example, so that the cost is really just the storage, right, but there's no electricity. And so I think that this kind of intersects that kind of sustainability, we're calling it cyber sustainability, is absolutely critical, right, for kind of how we think about data in the future and what we're going to keep and what we're going to throw out.
I'm Mike Nelson. I work on technology policy issues for Bloomberg government and also teach at Georgetown. We write about technology policy issues that impact our customers, who are mostly businesses, and they're fascinated by big data, and they're very worried about the manpower issues that Titus and Susie mentioned. Yesterday I did a piece on where are the data scientists coming from, and not all of them are computer scientists or statisticians. They're coming from a lot of other places, and they're also incredibly well paid. So that brings up two questions. How is the federal government going to be able to afford to hire any of the people they need to munch all this data? And do we need to be thinking about training people in departments other than computer science and statisticians and statistics? Are there any places where you've seen good models where big data skills are being taught in biology and environmental sciences and physics and the like?
So I just had a graduate student leave hopefully with a PhD soon, but for Amazon. And he's not interested in being a professor because the pay is worse, the hours are longer, tenure, etc. So just one commentary on the dollar question. I guess I see the training. I don't know that we should necessarily focus on. We shouldn't only focus on training researchers in academia and government, right? There's a larger societal issue there. We should be producing people for industry just as well as for others, especially given the decrease in the number of faculty positions that are available. So in terms of training programs, so I'm split between a computer science and a biology department, and I think it's really important that everybody realize that big data always has to be in a context. Yes, there are algorithmic challenges that are broad across large data sets, period. My lab works almost entirely on big data questions related solely to sequence data. So it's not computer science and it's not biology, it's right down the middle. And that's, so the training programs need to be joint between computer science and statistics and other things. And one of the challenges always for the data science field is how do you train a data scientist? Because they need to be semi-expert, partial experts in a lot of different fields. And so that's where these interdisciplinary training programs, they're explicitly interdisciplinary. That's where I think they can.
Can you point me to one or two that you think are really models that should be emulated and replicated?
Well, let me just make one point here. I think that, as Titus pointed out, that we probably don't want to create a training for big data scientists. I think we still need to train in particular disciplines, but increase awareness as much as we can. I mean, one of our speakers, Matt Martin, is a causality casualty of such a training program at UNC. We have a bioinformatics computational biology training program that gives certificates to students in other PhD and master's training programs, and it's a very rigorous additional education that one needs to go through. But you can have a PhD in a biology or environmental science field, but then get a certificate and be much more ready for the challenges that that scientists are facing now today.
Sky Bristol at USGS has told us about what he is doing in working with industry and with local universities, and so the industry can actually provide data sets. USGS can provide data sets that the university can actually use. Their USGS is providing use cases, and then they actually go to the university, work with faculty members to set up modules that are focused on the kinds of data issues that U.S. government agency is having or industry is having. So it gives the students an opportunity to think through kind of the domain issues while they're actually experimenting with different data mining techniques, machine learning techniques. So it's win-win for the agency or for industry because the next generation is being trained in your problems, right? But it's also good for the students because otherwise it's just very, very abstract, right? And so they need to understand that this is highly interdisciplinary. It's bringing together statistics, mathematics, software development, computer science, algorithm development, and it's all done within some domain, whether it's finance or pharmaceuticals or earth science, whatever it is. And so it is a huge challenge. But I believe that these multi-stakeholder partnerships that are growing up across the country are going to help us kind of do this on the ground in local areas.
One particular name, Hillary Mason.
Yes.
Has a blog post, Getting Started with Data Science.
Yeah,
she's
amazing. Yeah. Thanks.
Right, and there was a comment online about the new initiative that major universities have started with opening up their courses and making this free and accessible. So I think this is a very good point that Hangju from NIEHS is making online.
Lou Grossa, this is a comment about diversity. So I direct the National Institute for Mathematical and Biological Synthesis, which is part of an enterprise out of the Biological Sciences Directorate at NSF. And the history of this is that this is community-driven science. So that we, all of us, the variety of synthesis centers, there are now 4, all focus around the fact that we encourage the community to submit requests for our support. We're not a re-granting agency, but people submit because they're interested in bringing together the best people in the world to work on their particular research initiatives. And so this is, in part, one of the things that USGS, I think, borrowed with regard to working groups at the Wesley Powell Center. And it has been tremendously successful in that the people involved are doing this because they're interested in the research. The incentives are indeed solving challenging problems that they focus their scientific interests on. And in some cases, this incentivizes them because they do publish. And I'll give you one example of a faculty member at Arizona State, junior faculty member, who was, because of his activities in a working group at our institute, was hired away by Yale because they were so successful. So there are incentives like that. And I would encourage the federal agencies to think about the benefits of a diversity of approaches to solving problems that are particularly interdisciplinary, as are most of them in biology. And this is one route that is particularly useful. There's a good model for it, obviously, that USGS and others have taken on. And with regard to education, since Titus brought it up, I will point out that we believe as well in multiple routes to success at the University of Tennessee. So we have graduate students from a wide variety of different backgrounds working together on problems. On data science, this includes geographers, for example. And we found that to be very useful in building up issues like Jack Dongara and I have set up a computational science minor program that brings in people from a variety of different disciplines to pick up the basics in a domain science that they already have with mathematics and computational science as well.
Well, thank you for that comment. We'll go to the next microphone.
This is Linda Wennerberg from NASA. And I have to smile about the data immigrants thing because, to give you an idea of perspective, my dissertation was the first one in Michigan State that was ever typed on a PC. So when I'm looking now at the issue of the technical issues of big data, how are we going to manage all this data, what the role of the federal government is, I am not so concerned that we won't have the ability to deal with the technical aspects, and I think it's moving along very quickly. What I'm concerned about is the stuff that was talked about earlier in the meeting. We don't have the understanding of this fire hose of data of how to do integrative work on exposure. We don't have a ways to deal with these things. We're getting lots of data, but there isn't the understanding, that interdisciplinary understanding of looking across things at complex systems. And that's the thing I say back to the feds about. Because we have several roles. We basically provide money and incentive, we provide structure, but we also regulate public health of the country. And we're making public health decisions and also market decisions and so on based on the fact that we take one chemical at a time. Bill Farron's comment about take formaldehyde and we dose it, and when that's it. The question is, we have the issues about the mechanisms of the data, lots of data. But what is the federal government going to do about the fact of trying to find the integrative approach to actually use that data in a reasonable fashion? And I ask folks to think about, NSF may have good ideas, NIH, but I watch that now and go, we don't have the understanding to actually use that stream of data. Forget the mechanisms of getting it, just simply what do we do with it to really make sound decisions?
So I think I'm going to try to tie in a comment that was made yesterday about if we knew more about what happened in order that the internet got set up in the way that it did in terms of the role of standards. and go to something that Barbara mentioned yesterday in terms of what happens when, you know, and actually you and Bernie made yesterday, which has to do with sort of two different themes. One is, do you build interoperability so that particular projects can get done? Mm-hmm. Or do you do very specific projects that actually enable focus and solve in a particular an interoperability problem? And I think what people are finding, and I'm bringing it up because I want to make sure we don't have to, that many don't learn the lesson the hard way, is that it actually is individual researchers working on a particular problem that come up with a solution that may work in the particular, and then variations of that iterate to get to a way of looking at standards and interoperability, as opposed to, I'm going to develop a taxonomy, I'm going to tell you these terms are going to be used this way, these are the only ways you will put your data in. I think it's worth remembering lessons in history that actually practically solving on-the-ground problems of interoperability build to general solutions. And I think that it's a way of solving for interoperability and actually a on-the-ground direct approach that I would advise. And so then what's the role of the government is making sure that there are many simultaneous pilots going on, because there's no one group that actually will show the adjacency to the next. So having a series of projects, and along those lines, I think in environmental health, we had a discussion last night at dinner, having a sense of leadership in 2 or 3 themes that actually are considered domains in which information and science can go on, and sort of saying these are domains in which all these things can go on, is also, again, a sense of leadership that can help accelerate that process to getting that interoperability.
But I think this is a very important point, because you know, even though the title of this workshop is, you know, integrating data to advance discovery, I think, you know, you bring up a very important point. You have to move from discovery to actually using this in some form of a decision-making process. And I think that all of the talks late yesterday and this morning's discussion really brought up, you know, a lot of challenges into how to do that. But I think we probably haven't spent enough time talking about what are the institutional challenges and actually uptake for that information into making decisions. And I think there's a lot of hesitation, you know, from a variety of regulators in relying on new data and letting go of old data. And I think this, we just have to be very open about that. And therefore, I commented yesterday that trying to engage stakeholders and trying to build tools that help end users understand and use this data, the dashboard idea, you know, other types of engagements, in actually building those tools for the end users rather than necessarily just for the scientists, and to, you know, to be enamored with their sandbox, making it a larger sandbox with bigger data. I think that's a very important point that the government also has a role to play in.
I just request that the folks there's a lot of very, very bright folks here from various parts of the agencies, to look at the fact that we do have a responsibility to the issue of beyond just data, really having structures to use that data in decision making. And that's just something that it's very difficult. We all know it, but it just had to be said. Thank you.
Thank you for that comment.
Bill Farland, Colorado State. So I'd like to pick up on the theme that Lou just mentioned, and Stephen, I think, added to, and that's how the federal government can facilitate some of these. And Kevin, I had the opportunity to be involved in the launch of the Powell Center out at Colorado State, and I wonder if you just talk a little bit about how that center works, because I think that could be a good model for us to follow in terms of the environmental health area. And then I guess I'd ask you whether or not the center has actually taken on some of the big data issues at this point.
Sure, I'd be happy to do that. Thanks for the question. So the concept behind the John Wesley Powell Center for Analysis and Synthesis was to do exactly what the last question was focused on, which was, okay, how does synthesis actually occur today? A lot of the big questions require synthesis, And so one of the basic precepts behind it was this is not your typical science project or science question. In fact, no new data should be collected at the center. So it's a virtual center in the sense that there's a physical place where scientists meet, but it's proposal driven, and individual principal investigators get together and they team up. We want interdisciplinary membership on that team, not just USGS scientists, but outside organizations addressing a big integrative science question. And there's a process that we go through to get a sense of readiness, that data exists, that it's accessible, and that there is a methodology proposed within the proposal for how this data and information will be integrated. And in fact, there's a lot of work in terms of getting a group ready for that to occur. We assist them. My mission area, my office at USGS, provides a lot of basic IT support to that. Sometimes, scraping data from different sources, cleaning it, getting it consistency between data sets and so forth, to kind of prepare for the scientists to actually sit down and do various forms of analysis of that data. Each one has its own suite of challenges. I think it was said nicely here on the panel. But what we're trying to do with each working group is to come away with some methodologies that we can start to package, and then we can understand the next time we start looking at a similar kind of question or issue, the kind of things that need to go into that. We're still new in this. I think we're in our third year of the John Wesley Powell Center. We've gotten some we've got about 27 working groups all told today. Really broad, different kinds of questions, from impacts of hydrofracking on water quality to questions about tree rings and their ability to answer climate questions, and so I think some of the key points I've mentioned. It's a competitive process. It's a synthesis of existing data. It's interdisciplinary. These are some of the keys, and I don't think we have a lot of the answers to what are the actual methodologies that come out from synthesis. We're learning along the way as each working group takes it on.
Thank you. Stan?
Stan Ahalt from UNC Chapel Hill. I have two questions, and I'll try to be concise. First of all, is there any, and perhaps this is already being done and I'm just unaware of it, but I was struck by your digital curation tool, Kevin. Can that be put into the public domain so that it can be picked up by other agencies and, in fact, a university? And it seems to me like it'd be a great idea for sustaining it and improving it over time, because I think, if you all have a solution that's working for a particular context, another context might greatly benefit from having that in the open source. And then I have a second question I'll just pose briefly and then I'll sit down. Is there any, so this is to the larger panel, is there any impediments, policy, legal, legislative, to running competitions in a very different way? I'm thinking of, I was struck by this discussion of the pre-competitive space. Why couldn't you put an award out and say, there's $1 million to the best proposal, but it has to be developed in the open? And then you allow, so I'm thinking of the quirky model where, they have this ideation phase and people work furiously together and they ultimately kind of vote for who made the major contributions to a particular product, where in this case you could think of the product as a proposal, okay? And it wins. There's no panel involved. It's kind of a judgment by your peers on the fly. I think it'd be very interesting to run an experiment to see if you got a different kind of science out that way, where you let people kind of get together and agree on good ideas and spin things up jointly before you have the grant, in the process of putting the grant together. So think of a proposal as a process, or a product, sorry.
Sure, I'll take the first one there. The data upload and registry tool that I think you're referring to from my presentation. Is it open source? So first of all, I agree with the comment that you made. I think if you make it open source, that's definitely a goal of ours. And I know that we've done that with a lot of the products that we've developed. And you start to basically you expand access to the community and you build the community that way. I want to get your card because I think the answer is yes, but I would like to go back and verify that we've taken that and put it. I know it's open source. Whether or not we've actually put it out somewhere where it can be, in the public domain in a way that it can be modified and extended, I don't know the answer to that question. So let me take your card and try to get that answered. Okay.
So in response to the second part, I've been at NSF now for 15 years, and we've become increasingly experimental on the different approaches that we have taken to giving awards. And so I believe one of the things that you mentioned is something that started in the UK. It was called a sand pit. And I'm forgetting the gentleman's name, but he's now a facilitator, and he goes around the globe, I guess, running such exercises. And so we at NSF have adopted it. We call it an ideas lab. And so what happens is people apply to go to the lab. It's a 5-day, typically very intensive experience. They have to have explained why they have the expertise for whatever the ideas lab is about. Why they work well in team environments, why they're innovative, flexible. And then some numbers, so out of 100 applicants, 30 or so get picked. And they're invited to come to the ideas lab. And the idea is for people to pitch ideas in the beginning and then find partners through the course of the week, so that by Friday there's, so many, 10 groups of 3 or whatever it looks like, who actually have proposals that they've come up with together, even though maybe they didn't even know each other before, right? And so then what happens is those proposals actually then get submitted to NSF, and we have our choice as to how many to fund. But typically, the ones that get submitted are good enough to fund, and we're able to do it. So we have experimented a little bit with this. This has not taken over our traditional, panels and then giving individual grants, but it's worked out really well in a few programs.
Just two quick comments, one on the challenges, one on the data curation. On the challenges, look at the term co-opetition versus competition. And this challenge I talked about yesterday on breast cancer, remember that we ran that where people were sharing their code in real time, and we gave rewards for people who basically got to the top of the leaderboard by using someone else's code. And we found that if we didn't do that, they didn't. But if we offered them small amounts of money and said, and both of them got it, right? The person that was and the person that did, and I think this is very important. Whether it is Kaggle, whether it's Incentive, industry basically works with experts in a closed way and says, go off and do this. I think it's very valuable to run open challenges. And by that I mean where you have to show your code, and that allows someone else to make a discovery. So that's on the challenge. On the data curation, I want to make a point about the somewhere between infrastructure funding and research is a gap that I'm not sure people think about enough. And that is that a scientist who is heading forward on their project on air pollution has an interest in getting their paper published on that. A person who's able to write really good code is got to connect with that person. And in between those two is an element of what I'd say is scientists engaged in expressing what they're doing in a way that can actually get picked up by those who are professional code writers. And that's infrastructure in a different sense. Usually the infrastructure awards are, we made this platform, or we set up this data repository. There's a different element of infrastructure, which is the interface between the thinking scientist who's used to working in a silo and her counterpart that's sitting on the other side who actually could write the code for it. And that is really hard to highlight, or at least to recognize.
fund.
Thank you. We'll take 2 more questions and then carry on with the agenda.
Barbara Wold, this is a comment meant to stimulate more comment, and it's at the nexus of small scientist with big scientist and big data and the curation of it. And so the quote-unquote small scientist that is a potential consumer of big data is these days in many fields, I'm certainly aware of it in the genomics area, now entirely empowered to generate, if not something that is big data by itself, it's of a type that can contribute to big data. And there's now a lot of it. The question is what to do with it. So one thing is the kind of thing that's been talked about is kind of a presumption that if it's made in the course of what in NIH or NSF R01 kinds of grants, that it will just go to a database and become part of big data. What the ENCODE enterprise has encountered, first working out what to do as a large project, and then thinking about other data of its type, is the question about, is there a role for the federal government in both rewarding the quality of data from individual projects by saying, aha, it meets certain standards and should join an archive and be identified with a gold star for the fact that it's of that quality and that somebody has taken the trouble to put it there. And so it's not just an aggregation of all possible data of a type. And as a consumer of those data, as a downstream scientist, there's an enormous benefit to the quality curated archive as opposed to the global archive. And so I think there's a role, I certainly see it in biology. It hasn't fully gelled yet, but there's clearly a role for leadership there, I think. And I don't know how that spans across all fields.
Anyone from the government first?
I thought that was a great comment. And I mean, I think that incorporates many of the things that we've been talking about. So the leadership issue, I mean, what's the role of government in assembling the type of leadership to define visions and to develop scientific programs? And I'd like to think that big data or big science and small science can be merged, because as you say, there are a lot of small scientists that are generating big data sets. But if what we could do as part of that vision and scientific plan is kind of lay this out, and so that the scientific community as a whole can take a look at a website that lays out the scientific plan, then there may be a person who writes code that looks at this and said, hey, I know how to do this. So it's a little bit of a different model. So it's the big science model, but allows every small scientist or individual R01 funded scientist to do interesting work that's not only interesting in its own right, but also integrates with a bigger data collection project. And in fact, if you get at one of the issues Carolyn brought up, is how do you get recognition? Well, you may be a contributor to a large data project, but it's actually your R01. So your R01 is then funding, it's your R01, but you're virtually working together with lots of other scientists. I think it's a very interesting model that needs to be explored further, and it can meet so many of the different needs that we have in the environmental health sciences community.
I would just also say that the convening powers, which I thought was one of the other things that came out this morning so terrifically, how you can use convening powers at the beginning to say what you're going to do, and at these other levels. And the convening power is in not having some person whose name is probably not known to everybody in a federal office being the arbiter of quality or the person who sets the direction, but these ongoing community working groups that are actually the community itself saying what's useful, when you ratchet up the standards, what the award system ought to be. And then, the tenure givers will start to look at things like that, and they'll recognize it as being on the path to knowledge. And I think that's the other piece that can get lost and separate the big data community in a way that's not productive from the rest of the scientific enterprise. That is, the knowledge out the back end is the big reward. Universities are still and always voting tenure to see what knowledge do you have your name on that you pulled out the back end. And so at least making clear steps along the way, including but not restricted to that last pull, is I think, key.
Just a real quick comment off of this, and it's also off of something that was on the that Mark Newman was putting on the web. This concept of convening often is, let's bring our university experts together. I don't mean from an advocacy standpoint, I mean from an expert standpoint, engaging the disease communities who actually are very interested, they have the energy, they have the insight, they have the funds that actually will solve some of these problems in those times when we're convening. Sometimes those get left out of the process, and I would be surprised, so here's one of my challenges or thoughts is that I wouldn't be surprised in a decade from now that half of the research that's being done, that's giving us the data that we want, is actually being funded directly by citizens, not by the government. And we have to have a way, and that's the only way it's going to be affordable, and be ready for groups who get excited about a challenge, whether it's a breast cancer survivor, whether it's someone who has autism, to say, hey, guess what, we're ready to join in. And how to do that with all the biases that are there in doing that is something we're going to have to learn how to do. But I think convening, important. Remember to convene more than just the acknowledged academic experts.
Thank you, and we'll take the last question.
Hi, Meg Harmson. I'm with the NITRD program, a health IT coordinator with the Big Data SSGS. I just want to make this comment, actually. I had not heard this, and I wanted to share it if those of you did not hear about this before, should have. There is an open government initiative, and there is a place for some of the government data that's being put out there called data.gov. And one of the big proponents of that is Todd Park, who is our US CTO. And Todd came from the health industry and then was the HHS CTO. So over the last 3 years, 4 years, I guess it's been, maybe 3 years, it was his inspiration to do what he's called data liberation, to liberate the government's data and put it out into the public because we paid for it. And he's pushed that with health data, and there's healthdata.gov also that's part of the umbrella of data.gov, if you will. And basically, just wanted to share that this is out there. There's free data out there. It's a way for us to tie together data, discovery, and innovation. I think his big push has been to put the data out there, and the innovators will come, and it may be citizen innovators, citizen scientists, it may be industry trying to make a buck, whatever it might be, but there may be some good combinations there. Last Friday at the PCAST meeting, Todd Park gave a presentation on open government and talked about all the different health data innovations that have happened because of all this data being put out there, and said that he plans to use that as a template for rolling out health, not just data, health data, but data for energy, education, finance, I think patient safety, or safety, I should just say safety, and global development, I think. So this is something he's really jazzed about, and if you've ever seen Todd Park in any, in person or online, he dances, he gets very jazzed about all this stuff, and it may be another vehicle for this community to think about in terms of environment and health, and engaging with industry and just the general innovation community out there.
Thank you. This is a very, it's a great comment, and thank you for making it and pointing this out to us. On that note, I would like to thank the panelists and the audience for great participation, and I think they all deserve a round of applause. Thank you.